everyone, this is going to be a video channel called That Engineering Girl. I'm going to be going over several different basic engineering concepts. I recently graduated in mechanical engineering myself. I've got a few months before my real job kicks in, so I'm going to be filling up that time by making a whole bunch of videos. You can use this to help get through the studying for the FE exam. You can use this to practice studying engineering classes you're currently in, or you can use it to prepare for classes that you're going to take in the future. Heck, you can even use this because you just feel like learning some stuff. Today I'm going to be going over the basics of vectors. We're just going to hit just basic level stuff here. This video shouldn't take longer than 10 minutes. I don't think the others are going to take much longer than 10 minutes too. You're going to see these be very unprofessional. I'm just going to be putting pieces of paper and writing on this whiteboard here in front of me. So don't expect anything real fancy out of these. So without further ado, we're going to be talking about vectors today. So you're going to hear me talking about two different kinds of numbers often. There's going to be a few other kinds that we're going to talk about, but mostly it's going to be these two. Scalars and vectors. Everyone's really familiar with scalars. 2, 5, 134, 7.6. You can put units on there such as miles, quarts, cups. You can say apples, that can be a unit. Feet, anything that denotes what it is going to be a unit. Now, there's going to be something separate when you talk about vectors. It's going to have that magnitude, which just means the same as the overall number, the overall amount something is, and it's also going to have a direction. That's going to be saying 5 miles north, 1 mile east, 6 units in the x-axis direction if you're used to a coordinate system. That can also include -4. I include negatives with vectors because negative denotes that you're going the opposite direction on the number line. So that is telling you what direction you're going to be going. So let's think of a specific example. The difference between scalar and vector. What if someone asked you how far away you lived from a particular site, such as a school campus? You could say that you lived 5 miles away. That answers the question. But what if they needed to know how far away you lived so that they could get to your place? Well, then you could say I live 5 miles north, or I live 1 mile east. There you go, you answered the question, they can get to you. Especially if you just say 5 miles north, all they gotta do is drive 5 miles north and they find you. But what happens if you aren't exactly in a particular direction? What if you live 5 miles north and 1 mile east of a campus? So we're going to look at the math that goes between figuring out what the direction and magnitude is when you have two different components there. So here's a coordinate system that I set up. As I said, these are going to be kind of rough and unprofessional, so normally if you draw it yourself you should use a ruler and make this a much straighter line, but I was in a bit of a rush. So let's look at what happens when you go 5 miles north and then 1 mile east. You can't say that you're 5 miles north and 1 mile east if you just want to give them a specific number in a specific direction. So let's see here. Let's say that our direction is going to be this angle right here, okay? We're going to call this theta. That's a Greek letter if you've never seen that one before. Before we even get onto theta, let's figure out what their magnitude is here. With vectors, if it's in the 2D plane, such as what we have here with an x direction and a y direction, we're going to be running into how to set it up to where x directions and y directions, how they can form together. You can't just add them together because they're in two separate directions on the piece of paper, right? If you go 5 miles this way, you've not gone any directions this way. You've only gone straight up. So, let's look at what we've got here. Let's say anything in the north direction is in y. Let's say anything in the east direction is x. So you've got 5 miles in the y direction plus 1 mile in the x direction. Okay? Simple enough. Now let's look at it to where we can actually add them to be one straight number. If we look at this right here, we can make a triangle with this. We go 5 miles up, 1 mile over, and it makes a hypotenuse right here. We can try to use our different geometry methods to figure out what that length's going to be. I prefer for this one to use the right triangle rule, and that's going to be where you take 5 miles, square it, plus 1 mile, square it, and if this whole thing right here is called h, if this whole line is called h, it's equal to h squared. And that's the Pythagorean theorem. That'll work for any 2D plane where you've got a right triangle in there. If it's not a right triangle, this isn't really going to work, so you got to make sure that you have a right triangle. A right triangle will be formed anytime you have something just in the x and just in the y. You can also break things up into x and y directions, which we'll show you how to do in just a moment. But let's look at this one right here first. 5 miles squared, that's going to be 25 miles squared. You've got to still square the units. Plus 1 squared is just 1 mile squared, still equal to h squared. So we can take the square root of 26 square miles to be just the distance h. Excuse me. And that's going to come out to be about 5.1. It's going to come out to where h is about 5.099 and it goes on. So we're going to say it's about 5.1 miles. Okay, that's great. That gives you a magnitude, but that doesn't give you a direction yet, does it? Well, again, we can start to use our geometry methods and try to figure out how are we going to figure out what the angle is theta. Well, for this one in particular, we're going to be using tangent. Now let's draw a line right here. There are several different ways that you can figure this out. You can try to figure out what this angle is in here. You can try to figure out what this one is right here, which is the most direct method. I recommend always trying to find off of the x-axis, whatever angle touches the x-axis. And that's going to be, I'm going to show you in just a moment why that makes it easier. Even if you were looking for this angle right here, if you want to know that one, I still recommend finding this one first. And that's going to be, you're going to be finding tangent with this because you've got the y direction, which is opposite, and you've got the x direction, which is adjacent. So tangent of theta is equal to opposite over adjacent, right? Well, we can say theta is equal to inverse tangent of opposite over adjacent, right? Well, if you're always looking off of the x-axis, your opposite is always going to be your y direction, and your adjacent is always going to be your x direction. It's important to understand the definition of why this one's y and this one's x, because of the opposite and adjacent, but you can sort of keep it in your mind that it's always going to be y over x if you're going off of the x-axis. If you start going off of the y-axis, if you're looking at this one here, let's call this one alpha. If you're looking for that one there, alpha is going to be equal to tangent of x over y. See, it goes reverse. So it really depends on where you want to look from. Again, I always recommend going off of the x-axis. So if we have theta is equal to the inverse tangent of y over x, that's just the inverse tangent of 5 miles over 1 mile. Okay? And that's going to come out to be around 78, I should make this be about, not equal, about 78.7 degrees. I'm going to do this in degrees and not radians. Well, it's going to be about 78.7 degrees You can check that by making sure that, obviously, if it's going up more than it is over, it's going to be greater than 45 degrees, and because it's significantly going up more than it is over, it's going to be significantly higher than 45 degrees. So 78.7 is a pretty good number to have right there. So, if you wanted to give an exact answer to your friend, he might call you a geek for this, but if you wanted to give an exact answer to your friend, you could say, I'm about 5.1 miles at 78.7 degrees north of east, because you're going north from east with this angle here. You see, you go up this way towards north from east. In our next video, we're going to talk about taking different components and making one vector with it. But this is the basics of what a vector actually is, and I hope you enjoyed it, and send me any questions in the comments. Thank you.